And subsequently, the rover took the selfie of the lander. So rover is the chota bhai, Vikram is the bada bhai. So chota bhai has taken the selfie of the bada bhai, Vikram lander. And you can see the instruments mounted. I will show you better one if I have. Skip this. Yeah. You see the chassis instrument which is mounted. It has gone inside the lunar surface up to depth of 10 centimeter. ILSA is sitting over here, and the Ramba LP, you see the shadow of it falling onto the lunar surface. So all three instruments on the lander were fully deployed and they did their science. The landing site, as you all know, is now called Shiv Shakti, and it has been approved by International Astronomical Union. So it is the landing site where the India's Chandrayaan 3 Vikram lander has landed. And okay, let me show you how this. You will feel as if a toy is moving on the lunar surface, but it is all very controlled. See, this is a movie made out of 6 hours. It was not doing like this. And whenever we have to park this, we have to keep this solar panel at 90 degrees sunlight because it has to charge itself. So it used to move, charge itself, stationary at one place for several hours, and then again move for a certain distance. And that's how we are controlling from the ground. So this is the Shiv Shakti point where the lander landed. We actually started moving this direction, found this big crater. You see, we came back, started moving this direction. But then our geologists, who were there in the mission control, the planetary geologists, they said, no, we should go into this direction because there is a fresh crater over here. And we should expect some boulders nearby. So we started going to this direction. We do find some boulders here in this region. Then we navigate very closely to this another crater which you see over here. And then finally we made this rover rest over this place. So this whole journey is about 103 meters over a period of about 12 days. Because this whole mission was one lunar day. One lunar day is 14 Earth day, right? So this mission worked very well. Everything worked according to our expectations, both the lander and the rover. And this 6 experiments on board on the rover and the lander also worked very well. And these are some of the glimpses of the science which has come out. I will tell you, ILSA, is the seismometer. So it actually captured the seismicity of as the rover was moving onto lunar surface. It was able to give you the signal which suggests very clearly that the instrument is working very well. The Ramba LP, it has provided us information about the plasma distribution at a height of about 2 meters. And the chassis instrument, let me see if I have some more science. Yeah. So you see the chassis heading inside, and this has provided information about the temperature at 10 different locations within the 10 centimeter of the lunar regolith. And it showed that this temperature, highest temperature somewhere around 355 Kelvin, which is much higher than what was anticipated so far at that location. The temperature expected was around 330, but this was showing about 355 Kelvin. And finally we found that no, the problem is that the local geometry there where the landing site is at a slope of about 6 degrees. And 6 degree slope towards the equator, that means towards the sunlight. So because the sunlight is now almost falling on this, it is getting heated up, and which suggests that the local topography at 1 meter scale itself can have drastic changes in the temperature at the local locations of the moon. This information is now inverted to say that the landing site where we have landed, if the slope is somewhere around 14 degrees towards the pole, it can actually harbor water ice. That means you don't have to go to the poles to this sea ice beneath the surface. You can get even few centimeters beneath the surface at 70 degrees south itself. And that's why this paper came in Nature Communication. It has just got published on 6th, that is yesterday. And then we also had a heating experiment. Not only we had a continuous measurement of the temperature, but there was a heater which is sitting there at this location over here on this probe which was inserted. And this heater was on for 2 times, which provided us the thermal conductivity. Thermal conductivity, if you see for the moon at a depth of about 8 centimeters, is very, very low. That means the regolith is highly, highly known. turn is quite useful. That means the heat from the surface doesn't penetrate down, and which in turn also suggests that ice can be retained inside the surface of the moon because the heat is not propagating down. APXS, which is the stored conditions is like this and deployed conditions like this. This is an instrument which was developed in PRL, and I will show you how this was working. This is again a movie made from the camera from the lander. You see a white plate moving down here, and this is a place it is in the stable condition making observations. We used to make observations for 2 to 3 hours at a location, and then this plate will go up in the stored condition. Oops, why it comes down? Okay. And this was done for 30 different locations. Oh, this is me showing you. Huh? I did not expect this to show up. So this is actually the plate where this APXS is mounted, and this used to be mounted down to make observations. Essentially why? Because we need to reduce the height from where we are doing this measurements. It comes down to almost like 4 to 5 centimeter above the surface to make the measurement, and every time we make measurement it will come down, make measurement and come up. So this is a mechanical movement which was happening, and this is also a kind of what you call credit to our mechanical engineers that they devised this mechanical systems that was perfectly working very well for more than 30 times on the lunar surface over a period of 10 days. So these are all different locations where we had take measurements, and it provided us information about all the major elements, whether we talk about sodium, magnesium, aluminum, silica, potassium, titanium, chromium, manganese, nickel, and things like that. So all major and minor elements have been mapped, and this is the first observation of its kind which suggests that we have all these elements present there, including zinc. And that's why this paper came in Nature last year on 21st of August 2024, telling that we now have a grand tooth information about different elements present on the lunar surface. And this is the paper. After the whole thing was over, we thought that there is still a propellant left inside in the lander. Can we do a lift off by firing the engine and move little bit, because this was a part of our test for future, because we had to do sample return mission. And therefore we did this after a lot of thought process, talking about whether we can do it. You see here, this is the location when we landed. You remember this crater in the front. But then after hop test, we landed very close. You see the distance of this from here. It shows that it has lifted, moved, and then landed. Oh, what is this? Oh, there's a movie. Okay. I did all this yesterday night, so I don't even remember now that this was lying. So this is all rolled back. You will see the lift off very soon. You will not see anything. There will be lot of dust coming out because the engine is firing. You see here, completely filled with dust. You will see. Yeah, this one. And then it is coming down. Landed. You could see the shadow of the lander legs. That's it. And this hop test has become very, very useful for us for future, because now we know that there is not much issue of a dust, which we are all talking about earlier. And as soon as the lander landed back, the dust has almost disappeared. So that means at high latitudes, the dust is not a major issue. In addition to this, the propulsion module, which was in orbit around the moon, we thought, okay, can we bring that back also to an orbit around the Earth? That also we did, and this propulsion module which is going around the moon is now back and going around the Earth. That means we can bring back any object from moon's orbit back to the Earth's orbit. So these are all not a planned one, but since the capability existed, we said we should utilize that at the best, and both of these were also very, very successful. Aditya L1 mission, you all know very well. It was actually launched on 2nd September morning at around middle of the day. And in the night of 2nd September or early morning of 3rd September, we did the hop test. So we are actually there in the Sriharikota on 2nd September morning for the launch of the Aditya L1. Night we came back to Bangalore and had the hop test. So this is how the life of all the people who are connected with the missions, they are very busy. So this is a mission of its own, looking at the sun with 7 experiments, one of them being developed in PRL, which is basically the aspects Aditya L1 solar wind particle experiment. And it is now in orbit at L1. L1 is a point between Sun and Earth at a distance of about 1% away from the Earth and 99% away from the Sun. But the importance of this is that at this point you can continuously look at the Sun. What next? We are now talking about the Chandrayaan 4 mission, which is sample return mission. And this is going to be a very complex mission because you see here there will be 5 different spacecraft modules: propulsion module, descent module, ascent module, transfer module, and re-entry module. And there will be a lot of docking. You must have seen India has actually done docking in space on 16th of January this year, right? And this docking experiment is successful, which in turn gives us the technological edge to have this kind of missions where we actually have to do docking and undocking. And this will be a very complex mission, but its aim is to perform the landing, collect the samples, come back to the moon's orbit, do a docking, come back to Earth's orbit, and then re-enter into the Earth's atmosphere and land onto the surface. In addition to this, we are also working on the Chandrayaan 5 mission, which is called LUPEX mission, which is the ISRO-JAXA mission or Indo-Japan mission, where the lander will be from ISRO, India, whereas the rover and the launcher will be from Japan or JAXA. But here, the aim is to go into very close to the polar regions or into the permanently shadowed regions. Permanently shadowed regions means these are the regions which does not see the sunlight. Why? Because moon is almost vertical like this. And this is how the moon goes around the earth. So if you have craters in the polar regions, that means a dip in the surface, they will never see the sunlight. So these places become the deep freeze, where temperature can go down to 50 Kelvin to almost like 30 Kelvins. And therefore any volatiles can go and sit there and be there for ages. So the idea is to actually probe them, but then the lander and the rover needs to be charged. So you need sunlight. So you have to land very close to the permanently shadowed regions, in a region where you are seeing continuously the sun. So it's a contradictory requirements for science and for the mission or technology, because mission requires sunlight for charging, but science requires PSR to be there in the vicinity. And therefore it is going to be very challenging that you have to land very close to the permanently shadowed regions, and then the rover will go inside this kind of PSRs, do science, come back, get charged, then go into next PSR nearby. And therefore there is a lot of work being carried out to understand which is the best location where we have to land. And there is a lot of work being carried out by scientists from PRL also. And there are rectangles you see over here, or squares. These are possible landing sites which are both important from mission perspective as well as from science perspective. What next? We are also talking about mission to Venus. This will be the first mission of its kind to go to Venus. And Venus is very different planet altogether. It rotates very slow. It rotates in 243 hours a day. So its spinning is very slow. But the surface pressure is about 90 bar. It is like 100 times the surface pressure of the Earth. Temperature is about 800 Kelvin. And therefore the conditions on the surface is very hostile. But as you go up into the atmosphere, at an altitude of about 50 kilometers, you see the pressure is almost benign, like 1 bar kind of thing, and temperature is about 300 Kelvin. But these are the regions where you have clouds. Venus is completely covered with clouds which engulf the whole planet, and therefore you can't see the surface of the Venus. This picture which you are seeing over here is not the optical picture. This is the UV. It's a false color image. And therefore, Venus is difficult to probe down through this atmosphere, and you need different kind of instrument to look at the surface. And therefore, we are more interested to look at many of these features in terms of the surface topography, volcanism, dust, lightning and clouds, atmosphere, ionosphere, and various other interactions, including the superrotation. Venus is rotating very slow, right? But its atmosphere is spinning very fast. The clouds, you can see these clouds, it looks like they are moving. These are rotating at a very high speed so that they complete its rotation around the Venus in 4 days. Venus itself is taking 243 Earth days. So that means the atmosphere is spinning very fast. So there are many science objectives to understand the Venus in much more detail. In addition to this, for Mars, we have already gone to Mars as an orbiter. So our purpose is now to land onto the Mars. So we should directly land and do science. So this will be a kind of a Mars lander mission, which will have a rover directly and relay orbiter, where we will be transmitting the data from the rover to the orbiter, and orbiter will communicate back to the Earth. So these are the future missions, and we have a lot of other science missions which are being discussed, including the Chandrayaan 5 and 6 and beyond. And future is quite bright in terms of explorations. So all the young kids who are present over here, who are doing their graduations and post-graduations, you can think about doing planetary science, planetary geology, planetary atmospheric science, and many other aspects of planets, because there will be a series of missions which is going to go in the future. If you look at how the future is there, we are also talking about Bharti Antariksh Station. It is going to be established soon, and also talking about having not just the sample return mission but human landing on the moon by 2040. And this is a big task which is being given by Government of India to do this kind of missions. So that means there will be continuous series of missions which is going to the moon, and all missions will have both technology and the science. And we as a scientists are very excited about it, because we will get the chance to do more and more science on the moon. But then, what is the plan? The plan is probably to have habitat on the moon, and later on to use moon as a base for future exploration. Why? Because moon is 1/6 the gravity of the Earth. If you want to lift from the moon, you can lift 6 times a year. And therefore, if you want to do interplanetary exploration, probably it will be much easier to have a lift from the moon rather than from the Earth. So of course, these are for long-term future perspective, but certainly I believe that in the lifetime of some of you who are sitting over here, you may see human habitat on the moon. Thank you all. Thank you all for listening to me. Can I have the light now? If I light on,